Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in this lecture. Today we continue with our second heterocyclic compound furan. Furan. It is also known as furfuran. It is also known as furfuran, and we see structure of furan. The five-member heterocyclic ring containing one heteroatom as oxygen, it is known as furan. So this is furan. Now we see preparation of furan. First of all, we start with first preparation. Furan may be prepared from mucic acid. We discuss mucic acid structure in above lecture. In synthesis of pyrrole. So we well know about mucic acid. So first of all, we prepared furan from mucic acid. I write down structure of mucic acid. This is mucic acid, which gives furic acid on dry distillation. Dry distillation take place. So removal of carbon dioxide, and for balancing equation 3H2O removes, it gives furoic acid, and decarboxylation gives furan. Decarboxylation gives furan. This is first preparation of furan. Now we see second preparation. Industrially, furan is prepared by catalytic decomposition of its 2-aldehyde, that is known as furfural. In steam, furfural is generally obtained by the distillation of octahooks or mesicops, which contain pentose, aldopentose, with dilute sulfuric acid. So mucic acid and aldopentose have only some difference. So I write down this reaction is here because mucic acid contains COOH group, but aldopentol contains hydroxy group and aldehyde group. It is known as aldopentose. Aldopentose, with the help of sulfuric acid. It is converted into furfural. This is furfural, and furfural converted into furan. This is second preparation. Furan. Now we see one more example. This is known as pal nor, PALL nor, KNORR, par non synthesis. Pal nor synthesis. 1,4-dicarbonyl compound. 1,4-dicarbonyl compound on treatment with dehydrating agent such as sulfuric acid, H2SO4, SnCl2, phosphorus pentoxide, etc. are converted into furan. So it is known as pal nor synthesis. CH2 bond CH2, R R dash. This is 1,4-dicarbonyl compound. 1,4-dicarbonyl compound. Furan derivative. Methyl group is present, then 2,5-dimethyl furan. So 1,4-dicarbonyl compound on treatment with dehydrating agent such as sulfuric acid, stannous chloride, phosphorus pentoxide, etc. are converted into furan. This is known as pal nor synthesis. Now we see about structure of furan. Structure of furan. Furan has aromatic sextet, of which 4 electrons are contributed by 4 carbon atoms and 2 pair electrons are released by oxygen atom to the ring. Its structure may be represented as the resonance hybrid by the structure. So we draw here structure, resonance structure for furan. These are 2 pair electrons released by oxygen. Released by oxygen. This is the aromatic sextet for furan. 4 electrons are contributed by 4 carbon and 2 pair of electrons are released by oxygen atom to the ring. This is resonance hybrid of furan. Now we see electrophilic substitution. Furan undergoes electrophilic substitution at position 2 and 5. Position 2 and 5. Some of the important electrophilic substitution reaction. Here we see some of the more important substitution reaction for furan. So I write down furan in center as described previous. This is furan, and if we give number then 1, 2, 3, 4 and 5. So for electrophilic substitution, furan undergoes electrophilic substitution as position 2 and 5. Sorry, 2 or 5. 2 or 5. So some of important reaction we discuss here for furan. As for example, first of all we see nitration. So we get 2-nitrofuran. This is position 2 nitrofuran. If we takes place sulfonation, then position 2 SO3H. So 2-furan sulfonic acid. If acetylation takes place, then 2-acetylfuran COCH3. 2-acetylfuran is obtained if the formylation takes place. Then formaldehyde group enters at position 2. Aldehyde group at position 2. If bromination, halogenation takes place, halogenation, then 2 halo compound ClBrI, then 2 halofuran is obtained. If we takes place reduction of furan with the help of nickel as catalyst, then it is converted into tetrahydrofuran. It is tetrahydrofuran. If we takes place oxidation reaction, then it is converted into succinaldehyde, CH2CH2CHO this is succinaldehyde. So these are the different types of reaction of furan. Some derivative of furan is also obtained. Some derivative like tetrahydrofuran. This is tetrahydrofuran THF used in polymer industry. THF, and this THF is colorless liquid having boiling point 65 degrees Celsius and easily form an explosive peroxides. It is miscible with water as well as organic solvent, useful for preparation of hexamethylene diamine, and this is used in the preparation of nylon. This is the derivative of furan. The second derivative of furan, furan 2-aldehyde or furfuraldehyde or furfural. This compound is known as furfural or furan 2-aldehyde. Furfuran or furan 2-aldehyde. And property of this compound, furfural is a colorless liquid of pleasant odor and having boiling point 162 degrees Celsius with aniline and hydrochloric acid. It gives red color. This is furfural or furan 2-aldehyde. These are the component of derivative of furan, and this furfural, the most important use of furfural or furan 2-aldehyde is as solvent in vegetable oil and petroleum industry. So here we complete our second component, furan. Now we start third component, that is thiophene. Our third compound is thiophene. Thiophene and structure of thiophene. 5-member ring heterocyclic compound contains one heteroatom as sulfur. It is known as thiophene. Now we see property of thiophene. Thiophene is present in coal tar along with present in benzene and shell oil due to the closeness of its boiling point with that of benzene. Boiling point of thiophene is 84 degrees Celsius. 84 degrees Celsius, and boiling point of benzene is 80.04 degrees Celsius. So due to the closeness of boiling point with that of benzene, the two cannot be separated by distillation, and hence Thiophene is always present as an impurity in commercial benzene. In commercial benzene. Commercial benzene is known as benzol. The presence of thiophene in benzene may be detected by the appearance of a blue color with instant and concentrated sulfuric acid. So these are the basic information of thiophene. Now we see preparation of thiophene. Preparation of thiophene. First of all, we see by passing acetylene and H2S over alumina at 400 degrees Celsius gives thiophene. First preparation, acetylene, CH triple bond CH, 2 moles of acetylene and H2S hydrogen sulfide over alumina, Al2O3, and at 400 degrees Celsius it converts into thiophene. So 2 moles of, by passing acetylene and hydrogen sulfide over alumina at 400 degrees Celsius we get thiophene. Now we see second preparation by distillation of succinate. We write down this structure in previous preparation. COO Na. It is known as succinate. And this succinate is treated with phosphorus pentasulfide P2S5. So we get thiophene. Now we see next preparation number 3. By the direct reaction between sulfur and N-butane. Direct reaction between sulfur and normal butane. If we write down by this arrangement CH2, CH2, CH3, CH3, this is normal butane, N-butane, and sulfur powder S treated at 65 degrees Celsius, then it is transferred into thiophene. This is by direct reaction between sulfur and N-butane. This is sulfur powder. Now we see one more example for the preparation of furoic acid with barium sulfide. Here I write down, and last preparation number 4, by distilling furoic acid. with barium sulfide BAS gives thiophene and barium carbonate. So these are the four different types of preparation for thiophene. Now we see property of thiophene. Property of thiophene. Thiophene is colorless, water-soluble liquid, boiling point 84 degrees Celsius. Thiophene is more easily substituted than benzene, but less vigorously than furan and pyrrole. The new substituent usually enters on the alpha position if these are occupied on beta position. So this is the properties. Now we see chemical properties for thiophene. I write down thiophene in center. This is thiophene. If first of all we use this structure for if we takes place halogenation, then substitution in second position. So we get chloro, bromo, iodo, fluoro. 2 chloro, 2 bromo, 2 iodo, 2 fluoro, thiophene. 2 halothiophene. 2 halothiophene. If we takes place nitration, then we get 2 nitrothiophene. If we takes place in sulfonation reaction SO3H plus, sulfonation reaction takes place with the help of sulfuric acid, then thiophene to sulfuric acid. This is thiophene to sulfuric acid is formed. Acetylation takes place. Then acetyl group is introduced at position second, COCH3, 2-acetyl thiophene. If we treated by formylation, aldehyde group is introduced and second position. Thiophene to aldehyde, and desulfurization takes place with the help of Rennie nickel. Desulfurization takes place then it is transferred into normal butane. So these are the very important chemical reactions of thiophene. Thiophene can be Thiophene can neither be oxidized to sulfoxide nor to sulfone. So here we complete our third compound, thiophene. Today we stop here our this lecture. Okay, thank you.